Okay, so for question 9, 2 different graphs. Let's start with A. Now I'm going to do this in more than one go because I think it will be helpful. So for 1A, first of all, on here I'm going to sketch the graph of y equals cos x. And cos x, we should know, oh, I'm not drawn that brilliantly, looks something like that. Okay, now just thinking about our key points on our cos graph. This point here, if we were working in degrees, would be 360 degrees. We're working in radians, so this is 2 pi. If we're in degrees, this would be 180. We're not, we're in radians, so this is pi. This here would be 90 degrees. Again, we're in radians, so this is pi over 2. And this here is in blah, 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 would be 270 degrees. We're in radians, so this is 3 pi over 2. So that's just what y equals cos x looks like. But we're not asked for that, are we? We are asked, just going to fill this out again, for y equals cos of 2x. So what this means is this is a transformation like y equals f of 2x. And it means my graph is kind of being squished in, okay? What's happening is my graph is going to be stretched horizontally by scale factor 1/2. So with that in mind, it's still going to be the same shape, but all of these points are going to kind of be half the way from where they were before. So what I would do is I would think, well, this was pi over 2. So my new version, that point is going to be pi over 4. Before, it had like a minimum point at pi. So its new minimum point is going to be at pi over 2. So let's just label up these points now. And then let's label pi over 8. Oh, let's not label pi over 8. So we've got pi over 4, pi over 2. Then this point here, sorry, was 3 pi over 2. If we halve that, we get 3 pi over 4. This point here was 2 pi. If we halve that, we get pi. Okay, so we've got pi over 4, pi over 2, 3/4 pi, pi. Now let's just continue that kind of sequence. We're going up in like a quarter. So then we get 5 pi over 4. Then we would get, what would we get? I can't even think. 3 over 2 pi. And then if we're just adding on like a quarter pi each time, then we would get 7 pi over 4. And then we would get 2 pi. Okay. And now in terms of what the actual graph is going to look like, so still starting here at the point 1, but we're going to go down like this. We're going to have a minimum point at pi over 2. Then we're going to go back up like this. Then we're going to have a maximum point at pi. And then we're going to go back down like this. We have a minimum point. Okay, that's horribly drawn, sorry. We're going to have a minimum point here at 3 pi over 2. We're going to go back up through 7 pi over 4 and then have a maximum point at 2 pi. So all that's happened is the graph has been shifted, it's been squished in, and then it's been repeated more. Just to make it really clear, we're asked to indicate all points where they cross the axes. I've sort of done it on my sketch, but quite badly. So just to kind of be more specific with that, there is this point, which is pi over 4 along 0 up. There is this point, which is 3 pi over 4, 0. There is this point here, which is 5 pi over 4, 0. And then this point here, which is 7 pi over 4, 0. Okay, and that's how I would do part A. With part B, we want to sketch y equals tan brackets x minus pi over 2. The very first thing I would think about is what my normal, just ordinary tan graph looks like. And if it's easier for you to think about it in terms of 0 to 360, that is fine. So if I label up my 90, oh, let's not do that. This would be 90, 180, 270, 360. So what tan looks like is like this, and then it has an asymptote. And then it's going to have another asymptote here, which if you're working in degrees would be at 270. We're working in radians, but we'll get to that. And then the rest of the graph therefore looks something like this, and something like this. So now just let's label up our point. This is just y equals tan x. So kind of points we know in terms of radians. This here would be 2 pi. This point here would be pi, because this is 180. So this point here, this equation has got asymptote, let me use a different colour, 3 over 2 pi, it's like 1.5 pi. So this is the equation x equals 3 over 2 pi, okay? This asymptote here is the equation x equals half pi. Now we've got that, we need to think about this transformation. So if we think of this as y equals f of x minus a, the minus a means it moves a spaces to the right. So a spaces to the right. Okay, that's what we're going to try and do. Now, so all I would do is I would think, well, first of all, it had an asymptote, 1/2 pi. If I do 1/2 pi plus pi over 2, and you can use your calculator if you were like having a brain freeze, but 1/2 pi plus pi over 2 is simply pi, okay? So I'm going to have a new asymptote at pi. So if I label that pi, I know I'm going to need to have an asymptote. Okay? Similarly, this was 3 over 2 pi. If I add pi over 2, so 3 pi over 2 plus 1/2 pi is simply at 2 pi, so it's got a new asymptote at 2 pi, like that. So those are my asymptotes. These are going to be my new points of intersection, blah, blah, blah. So then in terms of the shape of my graph, it's the exact same shape as before, but everything has been shifted over. So it's going to be this sort of shape, like that, just better. And then similarly here, it's going to be this sort of shape, like that, it's a bit better. So in terms of R, we need to identify the equations of any asymptotes. So my equations of my asymptotes are x equals, this is x equals pi. This other asymptote is x equals 2 pi. And then we need to identify these points of intersection. So this is pi over 2, and this is 3 pi over 2. So as coordinates, that's pi over 2, 0, and then 3 pi over 2, 0.